Welcome back to this session. So today we'll be solving some more numerical. Let us start with the first one. Let me read its statement. A member A, B, C, D is subjected to point loads P1, P2, P3 and P4. Calculate the force P2 necessary if P1 is equal to 45 kilonewton, P3 equals to 450 kilonewton and P4 equals to 130 kilonewton. Determine the total elongation of the member, assuming the modulus of elasticity to be 2.1 into 10 raised to power 5 Newton per mm square. So, as you can see in this diagram here, has three different sections. So, we have section 1, section 1, section 2, section 3. Three sections we have, right? So this AB section, in AB section there are two forces acting, P1, P2, right? And in BC, P2, P3, CD, P3, P4. So in first section A, P1 is given equal to 45. P2 is not given, we need to find the value of P2. P3 is given 450 and P4 is given 130 kilonewton. So let us first find the force P2. After finding the force P2, we need to find the total elongation of this member. And this member, all three members, they have different areas. Their areas A will be different, only their modulus of elasticity E is same. So let us solve how we can solve. So let us first do summation of forces in x direction equals to 0. Now all the forces in x direction, remember, those forces which are going in left hand side is taken as negative, those going to the right hand side is taken as positive. So this is the sign convention. So first one we have P1. P1 is going to the left hand side. So I have minus P1 plus P2 minus P3 plus P4 equals to 0. Now let us put the value of P1. P1 is equals to 45. So minus 45 plus, we need to find the value of P2. P2 minus P3 is 450 plus P4 is 130 equals to 0. Now keeping all these numbers together equals to, now I'm taking this plus P2 to the right hand side direction. So it has plus here. When I take it to the right hand side direction, this here, it will become minus P2. Now let us find this value, how much it will be. So I have minus 45 minus 450 plus 130. So I'm getting minus 365. So it is coming minus 365 equals to minus P2. So this minus will get cancelled. So hence I have P2 is equals to 365 kilonewton. So I have P2 is coming equal to 365. So my P2 here is 365 kilonewton, right? Now we found the value of P2. The first condition for this question is over. Here it said calculate the force P2 necessary if P1 is equals to this. So the first condition is over. Now for the second one, we need to find the total elongation. To find total elongation, we need to take each section like we did yesterday. So let me take the first section AB. Right, so I will draw a free body diagram. I'll start from here, maybe free body diagram, right? And the section that I'm taking is AB, right? And its area of this section is 625 mm square. Now here it is in centimeter. Now I want to convert this into mm. So it will be equal to, this whole of this length will be coming equal to 1 20 into 10. So when I multiply it with 10, this centimeter will be converted to meter mm, right? And now let us find force at left hand side of this at A. Let's see what will be the force at A. So similarly, like we did yesterday, you draw a line, right? From here you draw a line, and from this section till here it will be the left hand side of AB section, and from here to here it will be right hand side of AB section. So we need to consider all the forces that are at the left hand side of this section. So what do we have? We have only one force, right? We have only one force, and it is going to the left hand side direction. So it is minus, right, 45 kilonewton, and the direction is going to the left side. So here I have force going to the left hand side, and it is 45 kilonewton. Now let us see at B. So at B, I have to consider all the forces at this point here. I need to consider all the forces that is running from this point here till the end D point, right? So what do I have forces? I have P2. P2 is going right hand side. So P2 is 365. Then next minus P3, 450 plus 130. So this will be coming equal to 365 minus 450 plus 130. So this is coming equal to 45 kilonewton, right? And it is plus, so it is going to the right hand side direction. So here right hand side, and I have 45 kilonewton, right? So what is the force P1 here? So for this, all this P1 force for this section, first section number 1, is coming equal to 45 into 10 raised to power 3 Newton. So we have P1 equals to 45 into 10 raised to power 3 Newton. Now let us solve for the second one, which is BC portion here. So let me draw the section. I'll draw the section here. Next I have BC. What is its area? Its area is 2500 mm square. Now let us find at B. What will be the force at B? Now I need to consider I need to take a line running from exactly from the midpoint of this B, and then whatever forces are coming to this side will be at left hand side, and whatever forces is coming from here to here, it will be at right hand side of BC section. So from this point till here, so first I have P1, then I have P2. P1 is going at the left hand side direction, so minus 45 plus 365. So here at B, minus 45 plus 365 will be coming equal to minus 45 plus 365. Minus 45 plus 365. It's coming 320 kilonewton. So it is 320 kilonewton, and it is positive, so it is going to the right hand side direction. So at B it is going inside, so here it is 320 kilonewton, right? This body here, it is under tension, right? Tension, and it is positive. It means that the length of this AB is increasing since this body is under tension. Now at C, let us find force at C. Now we need to consider all the forces from from this point till this point here, right? So what do we have? We have P3 and P4. P3 is going to the left hand side, so minus 450 plus 130. Minus 450, it is going to the left hand side, that's why minus, plus, see here, plus, because this 130 is, the direction of this force is towards the right hand side. So whatever force is going to the right hand side, it will be positive. So it is positive plus 130. So what do we get again? Minus 450 plus 130. So it's coming minus 320. Minus 320 kilonewton, and it is going to left hand side direction, and it is going to this direction, 320 kilonewton. Now this body is under compression, right? And that means it is gonna, the length is gonna decrease. Now what is P2 force for this second section? The force for this section is coming equal to 320 into 10 raised to power 3 Newton, right? It is 320 kilonewton, so I'm converting it into Newton. So we got it for BC also. Now let us find for the third point, CD. For CD, oh, I forgot to mention the length of this section here, BC. So length of this section is 60 centimeter, right? So it is 60. If I convert it into mm, this length will be equal to 60 into 10 mm. Length becomes this much, right? Now let us find for the last section. For the last section, CD, length is 90 centimeter, and we have P3 and P4. So we have CD, and its length is 90, right? 90, right? 90 centimeter. So we have 90 into 10 mm, right? And its area is 1250 mm square. Now let us find force at C. Now again at C, I'll take a half of this CD portion, half, right? Half. Now whatever forces is from here to here till this point here, I'm just taking from this point till this point CD, and the half of this CD, and this side it will be left hand side. Similarly this side it will be right hand side of CD, right? So at left hand side, what are the forces that are coming? P1, P2 and P3. So what I have? Minus 45 plus 365, minus 45 plus 365, and the last force was P3, which is going to the left hand side direction, so minus 450. So minus 450. What do we get? We get minus 45 plus 365 minus 450. So it's coming minus 130. Minus 130 kilonewton, and it is going, minus means it is going to the left hand side direction. So I have minus 130 kilonewton. And at D point, we have only one force, right? From this point, from here to here, I have only one force, that is P4 here, right? So P4 is going to the right hand side direction, so it is plus 130 kilonewton. So only one force, and it is going to the right hand side, plus 130 kilonewton. So I have here 130 kilonewton. Now this body is again under tension. So the length of this body will elongate, right? So what is the force here? P3 force will be equal to 130 into 10 raised to power 3 Newton. Now let us find the total elongation. So total elongation del L will be equal to del L1 plus del L2 plus del L3, right? So del L1 we have P1 L1 by, here all the areas of these sections are different, so we need to put A1 E, only modulus of elasticity is same, right? Plus P2 L2 by A2 E plus P3 L3 by A3 E. Now let us change its sign, okay? First one, for the first section AB, the section is under tension, so that means it is gonna elongate, so it is already positive here. We don't need to change its sign, it is positive here already, it is fine. Now BC section is under compression, that means the length of this section is gonna decrease. So here, instead of plus here, this section is under compression, so it will be minus, right? And this third section here is under tension, plus, so we have plus here, so we don't need to change. Now let us put the values. P1 was equal to 45 into 10 raised to power 3, and L is 120 into 10. into 10 raised to power 3 into L was 120 into 10, right? Divided by its area A1. How much was its area? Area was 625. 625 into, how much was modulus of elasticity given in the question? It was equal to 2 into 2.1 into 10 raised to power 5. So we have 2.1 into 10 raised to power 5. So this is our del L1 minus P2. How much was our P2? P2 was 320 into 10 raised to power 3. 320 into 10 raised to power 3, and its length was 60, right? 60 centimeters. So into 10 it will be mm, divided by, how much was its area? 2500. 2500 into 2.1 into 10 raised to power 5. So this is our del L2 plus P3 here we have 130 into 10 raised to power 3 into L is 90 into 10 divided by area. How much was this area? 1250. 1250 into 2.1 into 10 raised to power 5. So let us solve this in a calculator. (45) into 10 raised to power 3 into 120 into 10 divided by 625 into 2.1 into 10 raised to power 5 minus 320 into 10 raised to power 3 into 60 into 10 divided by 2500 into 2.1 into 10 raised to power 5 plus 130 into, I hope it will come, 10 raised to power 3. No, it's not coming. So it's not coming. I need to do till here, and then the last one I'll add it up, plus 130 into 10 raised to power 3 into 90 into 10 divided by 1250 into 2.1 into 10 raised to power 5. So the elongation is coming equal to 0.49. So it is coming equal to 0.49 mm. Since it is positive here, that means this is under tension, right? And it means that the length of the section has increased, right? So positive means it is under tension and the length has increased. So I hope this is clear. Let us solve the second numerical now. A brass bar having cross-sectional area A 1000 mm square is subjected to axial forces of 50 kN as shown in the figure. Find the total change in length. Take modulus of elasticity for brass equals to 1.05 into 10 raised to power 5 Newton per mm square. So in this figure, as we can see, there is only one force that has been applied for this whole cross-sectional area of the brass, right? So from the question, the givens are area is given equal to 1000 mm square, and then the force P is given equal to 50 kilonewton. Now let us convert this kilonewton to Newton. It will be 50 into 10 raised to power 3 Newton, right? Then we are asked to find change in length, del L we have to find, and modulus of elasticity E is given equal to 1.05 into 10 raised to power 5 Newton per mm square. Now as you can see, for each of this section, let it be 1, 2 and 3 sections, all of their diameters are different. So that means their areas will be different. So let us find area A1. Area 1 will be equal to pi by 4 d square. So the diameter given for this first section is 20, right? So 20 square will be equal to pi by 4 into 20 square. The area is equal to 314.16. 314.16 mm square. Similarly, A2 will be equal to pi by 4 10 square. This will be coming equal to 10 square. It's coming equal to 78.54. 78.54 mm square. Similarly, area 3 will be equal to pi by 4. D is 30 square. Will be coming equal to 30. It's coming equal to 706.86. So 706.86 mm square. So we have all the values that we need Now let us find the total change in length. So total change in length del L will be equal to del L1 plus del L2 plus del L3, right? Here this whole of this body is under compression, tension. The whole of the body is under tension, right? So we don't need to change any of the signs in here, so it will remain positive here. So it will be del L1 is equals to P. Now the load here, P is same for all these three sections, so P will remain same. P, L, length of the sections are different, right? 500, 200 and 800. So L will change. P, L1, areas are different. A1, E, right? Plus, similarly it will be P, L2 by A2, E, plus P, L3 by A3, E. So from here, let us take out the common. Commons are P and E, right? Here P, E. P and E. So this is common in all three. So we'll take this P and E, which is common outside. And the remaining inside will be L1, A1 plus L2, A2 plus L3, A3. So let us put the values. So force here, P is 50 kilonewtons. So it is already converted into Newton here. E is 1.05. So we have 50 into 10 raised to power 3, and E is 1.05 into 10 raised to power 5. Now L. L1 is 500, L2 is 200, L3 is 800. So L1 we have 500 divided by area A1 was equal to 314.16. 314.16 plus area L2 was 200 divided by area 2 was 78.54. 78.54 plus area 3 was 800. Length 3, L3 800, and area 3 is equal to 706.86. So let us find this, how much it comes. (50 into 10 raised to power 3) 1.05 into 10 raised to power 5 into bracket open 500 divided by 314.16 plus 200 by 78.54 plus 800 by 706.86. So here we are getting 2.51. So the total elongation is 2.51 mm. Since it is coming positive, we already knew that the body is under tension. It is under tension, so we got a positive answer here, and the length has increased, right? And this body is under tension. So I hope this numerical is also clear. Coming to the third numerical, the bar is as shown below. Find stresses in 3 parts and total extension of the bar. Take modulus of elasticity 2 into 10 raised to power 5 Newton per mm square. So now this bar is given A, B, C and D, right? Now what we have to find, we need to find the stresses induced in these three parts. So we have part number 1, 2 and 3, right? 3 parts. Now what is the formula for stress? Stress sigma is equals to force by area, right? The force is given here, but the areas we need to find it from the diameter, right? So let us find first area. A1 is equals to pi by 4 30 square. So we have pi by 4 into 30 square. So we're getting 706.86. 706.86 mm square. Next, A2 pi by 4 into 20 square. So we get, this is 20. So we have 314.16 again. 314.16 mm square. Area 3 pi by 4 into 32.5 square. So it is 32.5. So this is coming 829.58. 829.58 mm square. So we have all the areas. Now from this given area we can find the stress, right? So let us find the stresses. So stresses, right? In the first part we have sigma 1 for the first section, this section AB, right? So for first section, sigma 1 will be equal to P by area 1. So how much is my load? It is given in kilonewton, so we will convert it into Newton. 40 into 10 raised to power 3 Newton divided by its area is 706.86. So let us find 40 into 10 raised to power 3 divided by 706.86. So 56.59. 56.59. What will be its unit? Newton per mm square. So the stress in this first section is coming this much, right? So let us find stress 2. Sigma 2 will be equal to P by area 2. So P is 40 into 10 raised to power 3 divided by area 2 is 314.16, which will be coming equal to 314.16, 127.32. 127.32 Newton per mm square. Right? Now sigma 3. Sigma 3 will be equal to P by area 3 will be coming forces 14 to 10 raised to power 3 divided by area is 829.58. 829.58 will be giving you 829.58 48.22 48.22 Newton per mm square. So from this three stresses, we can say that this middle section is having more stresses as compared to these two sections. The section number 3 is having the least stress among these three sections, and section number 2 is having the maximum stress. So that means this section here, which is looking like a neck part here, is going under a lot of stresses when 40 kilonewton force is pulled opposite to each other. So now let us find the elongation, total elongation. Total elongation del L will be equal to, since all this section is under tension, it will be all positive. So del L1 plus del L2 plus del L3. So again, in this case, what is happening is that the areas are changing, and the length they are changing, but the force that is applied, P and E, they are remaining the same. So we can take out del L equals to P by E common outside, and length L1 A1 plus L2 A2 plus L3 A3, right? So P was 40 kilonewton, 40 into 10 raised to the power 3, and E is equal to 2 into 10 raised to the power 5, 2 into 10 raised to the power 5 plus L1 180 divided by A1. Area 1 is 706.86 plus L2 is 260 divided by area 2 is 314.16 plus third length is 160 divided by 829.58. So let us find. We should get a positive answer from here, because we know that whole of this section is undergoing tension. That means there will be increase in length of the section. So all this value should give us a positive answer. So let us find 40 into 10 raised to power 3 divided by 2 into 10 raised to power 5 into, bracket open directly, 180 divided by 706.86 plus 260 divided by 314.16 plus 160 divided by 829.58. So we're getting 0.26. 0.26 mm. So we got a positive answer here. That means this is correct. And the length is increasing. It is under tension and the length is increasing. And the length is increasing by 0.26 mm. So this is it for this numerical. I hope this numerical is also clear. So let's solve the last numerical for today's session. A composite bar comprising of aluminium and steel is as shown in the figure below. Find the value of P if the net elongation produced in the bar is 1.2 mm. So take modulus of elasticity for steel equals to 20 into 10 raised to power 4 Newton per mm square, and modulus of elasticity for aluminium equals to 7 into 10 raised to power 4 Newton per mm square. So here in this question, what are given? Given are net elongation produced. So del L is given equal to 1.2 mm. Now what are we to find? We are to find value of P. So we need to find value of P, right? And modulus of elasticities for two different materials are given, aluminium and steel. Now, as you can see in this diagram, there are different forces acting in here. So we need to find the equilibrium forces first. So let us first draw the free body diagram. I have A and B, right? I'll name this as A, B and C, right? So at A, I need to take half of this section, and this AB section from here to here, it will be the left hand side, right? Left hand side, and from here till here it will be right hand side of AB section, right? So at A, I have only one force, P, and it is positive, and it is going in right hand side direction. Positive P and in right hand side direction. So I have P in right hand side direction. So at B, at this point, so I need to find the equilibrium force at this point. So first I need to consider all the forces at right hand side section. So I have minus 4P, it is going to left hand side direction, then 3P plus 3P. So it is coming minus P, and it is going in left hand side direction. Minus is the left hand side, minus P. So this body AB section here is under compression. So what will happen? The length of this body will decrease. So what is P here for this section? Let us name it as P1. For this section 1 is coming equal to P kilonewton. Like, or the forces are not mentioned, so just keep it as P here, okay? And let us draw the FBD for second diagram, BC. So for BC, B and C at B. Now I need to consider this much, right? So whatever forces are from here to here, it is my left hand side, right? And from here to here, it is my right hand side of BC, right? So at this point here, from here till here, there are two forces, plus P and minus 4P. Plus P and minus 4P will give you minus 3P, right? And it is going in left direction. Minus means left. So minus 3P. So at C, we have only one force, 3P, and it is going in right hand side direction, so it is positive. So it is 3P. Now this body is under tension. It means that this body length will increase. Now the length of this body here, AB section, is given 1.5 meter. Now how do we convert meter to mm? It is 1.5 into 1000, so 10 raised to power 3. And similarly here, the length of this body is 1.8 meter, so it will be 1.8 into 10 raised to power 3 mm. Okay, now let us find from the formula of total elongation, we can find the value of P. So total elongation del L is equals to first section is under compression, so I have minus del L1, second is under tension, so plus del L2, right? So minus P1 L1 by AE. So the areas are also different. Area 1 and modulus of elasticities are also different, so E1 plus P2 L2 by A2 E2. So how much do we get? Minus P, value of P here is equals to P, so I have P only, P, right, into L1 is 1.5 into 10 raised to power 3 divided by area A1 is given 300 mm square, so 300 into E. Modulus of elasticity for aluminium here is given 7.7 into 10 raised to power 4. So 7 into 10 raised to power 4 plus P2 here is equal to 3P. So 3P into the length is 1.8 into 10 raised to power 3 divided by area is equal to 75 mm square into modulus of elasticity for this steel is equal to 20 into 10 raised to power 4. So we have 20 into 10 raised to power 4. So this will be coming equal to, see what I'm gonna do, I'll be showing you how to do it in a calculator now. I'm keeping this minus outside, bracket open, so P will remain as it is. So finally when I put all the, when I get the, see, I'll show you how, 1.5 into 10 raised to power 3 divided by 300 into 7 into 10 raised to power 4 will give me minus 7.14 into 10 raised to power minus 5 minus 7.14 into 10 raised to power minus 5 P. Now this P I still need to take it on. This P will come as it is P plus, now the second one, 3 into 3, I have 3P, right? So it is multiplied, P will remain as it is, so keep P as P only for now. 3 into 1.8 into 10 raised to power 3 divided by 75 into 20 into 10 raised to power 4. So this one you're getting 3.6 into 10 raised to power minus 4. 3.6 into 10 raised to power minus 4 P. Now minus this minus 7.14 into 10 raised to power minus 5 is giving you 2.89. Let us make it 2.89 into 10 raised to power minus 4. So 2.89 into 10 raised to power minus 4 P I'm getting. Now what is the total elongation given in the question? The total elongation given in the question was 1.2 mm. So I have 1.2 here. So here also I'll get 1.2 and 1.2. Now from here I can find P from here, from this expression. So it will be coming equal to 1.2 divided by 2.89 into 10 raised to power minus 4. So this will be coming equal to 1.2 divided by its answer. So it is coming 4,158. 4158, and its value here will be in Newton. Okay, it will be in Newton. Because why in Newton and not in kilonewton? Because all the values that we have taken, the modulus of elasticity here is given in Newton per mm square. So it is Newton per mm square. That's why the value that you get force here will be in Newton. So if we convert this 4158 Newton to kilonewton, it will be divided by 1000. So 4158 divided by 1000 will give you 4.158 kilonewton. So this will be the force. I hope this numerical is also clear. This is it for today's session. We'll cover more numericals in next session. Thank you.